Chapter 6 test will come in one big test. It will consist of, I think, 20, maybe 20, I think right around 20 questions total, covering all the different aspects of Chapter 6 that we went through. So let's just begin with some examples. And here you're going to have to find the parts of the triangle. Because we know angle B and side B, we can use the law of sine. So we have 4 over the sine of 25. It's equal to 6.2 over the sine of A. And then we also could find C and then the sine of C. And so in doing this, we would take 6.2 times the sine of 25 and then divide it by 4, and you would get the sine of A is equal to 0.655. And so A equals the inverse sine of that. And you will get A is equal to 40.9 degrees. So if A is 40.9 degrees, that means angle C is going to be 25 plus 40.9, 180 minus that. And that will get you angle C to be 114.1 degrees. And so then if you substitute 114.1 degrees here, and now you have to figure out side C, you would take sine of 114.1 times 4, divide it by sine of 25, and then you would get C is equal that's what you're doing. And so then C is equal to 8.639. Now, you are not done with this particular problem yet, because anytime you use the law of sines and you're only given one angle, you have to check to see if there's a second triangle that possibly could work. And that would come into play right here. You know that the angle is 40.9, and if you think about your unit circle, 40.9 is right there. And so the other angle that would mirror that would be this angle up here, where that's 40.9, making this angle from there to there 139.1 degrees. Now, can you have a 139.1 degree angle with the angle you already given? 25? Yes, you can, because 25 and 139 is not 180, and it's not more than it. So then angle A could also be 139.1, which then renders angle C to be 15.9 degrees, because you take that plus 25 and then take 180 minus that whole thing. And then you have to go through and do this all over again and put in a 15.9 degrees. And then do the same thing. So side C is going to be sine of 15.9 times 4 divided by sine of 25. And in this case, C will equal 2.59. And now you have solved it for the correct things. Second question. Here we have angle B is 150, A is 10, and B is 20. Again, we have a side and an angle opposite, so we can use law of sines. So it's 20 over sine of 150 equals 10 over sine of A, and then C over sine C. And so now we have 10 times sine 150 over 20 equals sine of A. And this time, A is going to equal inverse sine of that, which is approximately 0.25. And so angle A is 14.5 degrees, which then makes angle C 150 plus 14.5, which is 164.5, and then that makes this 15.5 degrees. And if you put 15.5 in here, And then you're going to have to figure out what C is. So C then equals sine of 15.5 times 20 divided by sine of 150. And that will equal 10.7. And so side C is 10.7. Now again, you've got to check because we got an angle A here. And so if A is 14.5, the other angle that would work, there's 14.5, would be that one, and 180 minus 14.5 is angle A could also be 165.5 degrees, which you can't have 165 and 150 degree angle in a triangle, so therefore our second triangle is non-existent, and we only have one to deal with in this particular problem. All right, moving on then. Find all the different angles. Doesn't matter which one you pick first. We're going to go with 19 squared equals 7 squared plus 15 squared minus 2 times 7 times 15 times cosine of C. And let's see, if we subtract 7 squared and subtract 15 squared, we will get 87 equals a negative 210 cosine C. That does not go with those two things because there's a minus sign here, but there's a multiplication sign here and there, so all of this is grouped together. Please don't make that mistake because it's really annoying when you can't just do a simple order of operations thing. All right. Now then you divide by a negative 210 and negative 210, and cosine of C is equal to 87. Wow, that's not a 7. I'm having problems with just simple writing of numbers. Over a negative 210, and so then C is equal to the inverse cosine of that. And so angle C is equal to 114.5 degrees. And then you can use your law of sines to figure out the other parts. So you have sine of 114.5, and C is 19, and then equals 15 over sine of B, and then you're going to have to do it another time. You don't have to do it a second time. So now, if you're going to figure that out, then B is equal to inverse sine of 15 times sine of 114.5 over 19, and so B is 45.9 degrees, and that then would make angle A 19.6 degrees. Approximately. Actually, 19.5. Or no, 6, that's right. And there you have it. All right, then. Have this question here. Cars traveling due west. A landmark is located north 62 west from the car. So north 62 west from the car. So it's up here. Maybe bring that down so you can see it. All right. Then it says after 5 miles, so now the car has driven 5 miles. Now It is north 38 west. How close will the car get to the landmark? So it's going to continue on this path. We need to find that distance right there. Okay, so then this angle total from there to there is 128 degrees, because that's 90 plus 38. If you know this is 5, and this is 62, then this angle right here is 28 degrees. And so now you can figure out either one of these sides, the green one or the aqua one. It really doesn't matter which one you use. So let's go with, oh, the aqua one. Because now you have, if that's 128 and that's a 28, that's 156 total, which makes this angle 24 degrees. So then you can say 5 over sine of 24 is equal to, and we're going to call this value right here d. D over the sine of 128 degrees. And so then you will get sine 128 times 5 divided by sine of 24. And you will have t is equal to 9.686. Okay. So then in this triangle, we still have sine of 28. And this time we're going to put x on the top of it. And let's see, we know this is 9.686, and that's the hypotenuse. And this angle right here is a right angle, so you can do sine of 90. Or you could have just said sine of 28 equals x over 9.686. You'd get the same thing. So sine and so then you'll get x equals 4.547, so we'll say 4.55 miles. That's this distance right here. All right, so now we have, to approximate the length of a lake, a surveyor walks 425 yards from point A to point B. So this is 425. The surveyor then turns 65 degrees, so that's this angle right here, and walks 300 to point C, which is on the other side of the lake. How long is the lake? So we're trying to figure out this length right here in green, and so we can use the law of sines, because we know that since this is 65, that has to be 115 degrees, because it has total 180. And so then you can say x over the sine of 115 is equal to, no, you can't use the law of sines. That's just not right. you can use the law of cosines and say that, oh, since that is b, we'll say b squared equals 300 squared plus 425 squared minus 2 times 300 times 425 times the cosine of 115. And then b will equal the square root of that whole thing. And so when you put that all in your calculator and take the square root, you're going to get 615. So this is 615 feet. Now then we get into some vectors, and this wasn't supposed to be here for you to see. Alright, so first thing, an initial point is at 3, 5. That would be up here. The terminal point is negative 2, 7. That would be there. We are supposed to put it in component form. Component form means that it's just like this, where the center or the starting point is 0, 0. So we got to take this and move it down to here. And so this coordinate right there is 3 minus negative 2. Or no, negative 2 minus 3, so negative 5. And then negative 7 minus 5 is a negative 12. And there's component form. Then the magnitude is going to be a negative 5 squared plus a negative 12 squared. And the square root of that whole thing, which is going to get you 13. Then the unit vector, remember a unit vector has a magnitude of 1, so if this is our magnitude, we just have to take and divide it by that. And there's our unit vector. And the angle that is formed between for this vector, you would want to do inverse tangent of 12/5. And that is 67.4 degrees. That's not a good degree symbol. That's a good degree symbol. But now remember, this is in this quadrant over here, so we're not talking that angle right there is 67.4. We need to find this angle from there to there, so we got to add 180 to it. And so our angle is going to be 247.4 degrees. You can also take the inverse sine of that or the inverse cosine of that and come up with the same thing. All right, so now we have u is that and v is that. Find the following, u plus v. So that would be that plus that, which is a negative 3i. And that plus that would be a negative 4j. And I think that's it for that one. Or if you want to, you can write it with in component form. Okay, so then u minus v would be that minus that, which would be a negative 11i. And then a negative 3 minus a negative 1, which would be minus 2j. Or as I said, in component form, it would be this. Either way, it doesn't matter. 3u then, take 3 times that would be a negative 21i minus 9j. And then 2v plus 5u, well 2v is a negative 8i minus 2j. And 5u would be a negative 35i. And a negative 15j. Combining those things, you would get a negative 27i minus 17j. Finding the angle between the vectors, here's what they look like. We're trying to find that angle. And remember that is in cosine of theta equals u dot v over the magnitude of u times the magnitude of v. And so if we go back up here, u dot v is this times that plus that times that, and that will get you a negative 28 plus 3, which is a negative 25. The magnitude of u, magnitude of this is that squared plus that squared and the square root, and that is going to be the square root of 58, and this squared plus that squared and the square root, and that is going to be the square root of 17. So we have square root of 58 times the square root of 17 which is the square root of 986. And so then theta equals inverse cosine of a negative 25 or the square root of 986. And that is 142.77 degrees. Or if you want to go 142.8, that would be okay as well. All right, now graph the vectors and the resultant vectors. Find the magnitude and direction of the resultant. Well, I've already graphed them and given you what the result looks like. So the blue one is 12 cosine 82 sine 82. Actually, no, that's not the blue one. That's the red one. That's the red vector, this one, where this angle is 82 and the magnitude is 12. So then to figure out what that vector is, you would multiply 12 cosine of 82, which is 1.6 and 11.8. Because you take 12 times cosine and 12 times sine of 82. And then the blue one is this one here, and again you take 8 cosine and sine, and you will get, oh, what's the other one? 7.8 and 1.6. And then adding these two things together, you will get 9.4 and 13.4. That's this green one. Well, now it's yellow. And then the magnitude of it is that squared and the square root. And so then the magnitude is 16.4. And the direction angle would be to take inverse tangent of 13.4 over 9.4, and that is going to be 54.9 degrees. So cosine 54.9 comma sine 54.9. All right, so an airplane leaves an airport at a speed of 724 with a bearing of north 30 east. So that's like this. That's 30 degrees going there. This is 724 because the magnitude is like the speed of the plane. So if that's 30, this angle is 60. And so then the vector is 724 cosine 60 sine 60. It then says the wind velocity is from due west at 32 miles per hour. That's going directly like that at 32. We should probably move it over here so it's like this, 32 miles per hour. So, well, we're going to have to shrink that because that's not geometrically correct. Let's put it in a darker color too. So that is the wind speed at 32. So this coordinate would be magnitude is 32, cosine 0, sine 0. And so then if you take that and move it up here, this is the actual plane where it's actually flying because the wind is going to push it. And so you have to take these two things and add them together. So you're going to take 724 times cosine of 60 plus 32 times cosine of 0. And you will get 362. And then you'll take 724 sine of 60 and 32 times sine of 0, which is going to be about 627. And that's that vector. And so then, in order to figure this out, if you want to figure out the speed of the plane, you would take this squared plus that squared, and then take the square root of it. And that will get you 723.99. So almost 724 miles per hour. And the direction it's going would be inverse tangent of 627 over 362. Which is approximately 60 degrees. It's like 59.9. Or wait a minute. Yeah. Oh, did I just mess that all up? I was looking at the wrong stuff. Hold on. Let's start over. Sorry. Let's see, if you take 724 times cosine of 60, you get 362. And then you add 32 cosine of 0, you will get 394 is your vector, x value. And then if you take 724 times sine of 60 plus 32 sine of 0, you will get 627 point stuff. So this is your vector. That is that vector there. Now, to find the height, or the magnitude, square those two things and take the square root. And you will get 740.5 miles per hour would be the magnitude or the speed of the plane. And then theta will be inverse tangent of 627 over 394. So theta is equal to 57.86 degrees. And so then the direction of the plane would be north 32.14 degrees east, because we need that angle, not this one. And we aren't going to deal with that one. So then write the trig form of this. And let's see, 5 minus 3i. If you were to graph it, there's 5 minus 3i, and the trig form would be the absolute value which is 25 plus 9, so the square root of 34. And then what's this angle? And then let's see, we would want to do inverse tangent of negative 3/5, which to do that would be a theta, well, not theta. This angle would be a negative 30.96 degrees. So then we would say cosine of 329, comma, or no, plus I sine 329. And there's trig form. And then you will have some other ones where you're going to do some multiplying. Remember, if you get something like the 2 cosine 20 plus I sine 20, and you're going to multiply these two things together, you just multiply, so you get 2 square root of 34, and then you add the angles. So that would be 349 plus I sine 349. And if you were going to divide them, then you would take the square root of 34 over 2, and then it would be cosine, and now you'd subtract, so you'd be cosine 309 plus I sine 309. And that is what's on your test coming up shortly.